All right, hello again. This is part two of our video for 10.2. Then part one, we walked through how to use Excel to recreate um, the plot of pH versus volume added, the plot of 10.1 and the table 10.1. And we split it up into three separate regions and did different calculations each time. And now I want to show you how we can use logic. What I mean by logic, I keep saying that. What I mean is like um, kind of like Boolean logic or computer logic. So we can say, if this is true, then do this. If this is true, then do that. And so you can write this in more sophisticated code, but you can do this in Excel also. And it, like most of these things, it takes a little bit more work up front, but then um, the benefit is then it's done and you can adjust it and use it again and again. It's kind of like automating, right? Once you've thought through it once, you don't have to think about it very much. Okay, so I want to look at there's basically two different situations, right? There's the one where before the equivalence point, we have OH minus unreacted, and after the equivalence point, we have H plus in excess. So if we wanted to find um, the amount of moles unreacted, well, first we have to check and see is the initial OH minus greater than the amount that we added? If so, we'll take moles of OH minus, subtract away moles of H plus added. If we've added more H plus, we don't have any moles of OH minus excess. And so then we would say, there's zero unreacted. So the way we can write that is, this is just kind of using words first, but if moles of OH minus unreacted is greater than moles of H plus added, then moles of OH minus unreacted would equal moles OH. Whoops, I made a mistake. I'll go back. This here should say initial. So if this is not true, right? This is weird. We say if this is true, then this, else equals 0. Right? Because if the uh, moles of OH minus that you initially had is less than the moles of H plus added, then the moles of OH minus unreacted is 0. There isn't any left. We look at moles of H plus in excess. We can ask the same question. Are the moles of OH minus initially is greater than moles of H plus added, then the amount of H plus excess would be 0, right? If that's not the case, if then or else, so basically like if it's true, we get the first line. If it's false, then we'll take moles of H plus added minus moles of OH minus initial. Okay, I should actually probably pause here and talk about if-then statements a little bit, just in general. So this is why I'm calling it logic, right? Because this is like you're looking at if something is true, then something else happens. And so in our case, we like, some value that you care about is conditional on something else. So it's like you could say that C is conditional on the relationship between A and B. And so like if A is greater than B, then C will equal X. If A is less than B, then C will equal Y. So this type of situation. And X and Y can be anything. So one way we can um, write this out would be like here's cell C, okay, and we're going to say if A is greater than B, then C equals X. So that's the true, right? This would be the true case, the true outcome, and the false outcome. These are conditional outcomes. And instead of writing another condition where we say if A is less than B, we could just say if this first case is not true, right? So if A is greater than B is equal to X, in all other cases, or else equals Y. Okay, so that's what we've just set up in our specific problem where C is the moles of OH minus unreacted, right? Or in moles of H plus in excess. But we can do the same thing for pH, because remember the way we solved for pH was different. So here's our pH logic. And here we're going to say remember that if the moles of OH minus unreacted was positive, so that's greater than 0, then pH was 14 plus log of OH minus. Right? If that's not true, then, or else, I'm going to put another condition. If moles of H plus added is greater than 0, pH is equal to negative log of H plus. If neither of those conditions are met, what is the pH equal to? This is region 2, right? 7. Either moles of OH minus is positive, or moles of H plus added, or excess, this should say excess, is positive. But if neither of those are true, then what we have left is region 2. All right, so that was just a little bit of a primer. Now we're going to implement this into Excel. Okay, it's not as bad as it as it looks. As we walk through it in Excel, I think it should make some more sense. So we'll do that next.